Hi ladies. Alright, so in this video, last week we discussed what's the difference in size between cations and anions. Now, just as a reminder, let's take a look at what's a cation and what's an anion. So, for example, I might have like Mg, okay? And I might have Mg plus 2. Alright, these are not the same. The one without the charge, this one is called a neutral atom. And once it has a positive charge, we call it a cation. And maybe you can see the plus sign here will help you to remember that it's a cation. This is a cation. So when it says ion here, it's referring to cation or anion. This is a cation. It's a positively charged ion. All right? Now what about a cation? Let's look at a cation. For example, O and O minus 2. All right, these are not the same thing. This O is a neutral atom, does not have a charge. This O minus 2 is called an anion. Anything that has a minus charge is called an anion. So what we're discussing in this lesson is the difference between cations and anions. Now let's take a look at the difference in sizes here. All right, let's scroll down. Now here you have Na, and here you have Na plus 1. Okay, this is for the cations. We have Na and we have Na plus 1. Now, Na, if you look, has 11 protons and 11 electrons. Na plus 1, the plus, it means this plus sign, it doesn't mean add. This plus sign, it means lose 1 electron. So here we had 11 electrons, now we have 10. So who's going to be smaller? The answer is the cation, the one that loses. Now that look at the anion. The anion is different because this minus here, it doesn't mean minus 1, it means add 1 electron. So the chlorine atom has 17 electrons, but the chlorine ion has 18 electrons. You add 1. So who's going to be bigger? The Cl. So anytime you have an anion, it's going to be bigger than the neutral atom, but if you have a cation, the neutral atom is going to be bigger. All right, go ahead and pause the video and look at this practice. Which atom or ion is bigger? Circle the one that is bigger. All right, are you ready? Let's give the answers now. So for the first one, which one is bigger? We have a neutral atom and we have a cation. All right, who's going to be smaller, the neutral atom or the cation? The cation is smaller, so this means this is bigger. All right, the next one is negative. Negative is anion. All right, look at the anion. Here's the neutral atom and here's the anion. Which one is going to be bigger? The anion. All right, because this minus 2, it means gain 2 electrons. All right, next one, Ca or Ca plus 2. Which one is going to be bigger? This is a cation. So you have to look in this section. Which one is bigger? It's going to be the Ca. All right, let's move on. All right, now let's take a look at the general trend in the size of the ions. Now, this side of the periodic table, this is the side that has the metals. Okay, all of this is the metals. Now, metals, they form cations. So you can see here, it's cations, size of cations. The other side of the table here, this is the anion section. All of this is the anions. And you can see here that it says anions, okay? Be careful. So what happens to the size of the cations as you go down? You can see that they increase. And what happens as you go to the right? It says that they decrease, all right? Then here we stop the cations and then we start the anions. So you can notice the anions here, they're a little bit bigger than the cations. So take a look at this table. As you go down, the size gets bigger. And as you go this way, they get smaller, okay? Now, that's for the blue ones. These are the metals. Okay? Now, if you look at the non-metals, as you go this way, they get smaller. And as you go down, they get bigger. Okay? It's the same thing. But you can see there's a little bit difference here between the metal and the non-metal. That's why we have 2 arrows there. All right? So go ahead and make note of the trend, the periodic trend. Increase down, decrease to the right. All right, the next thing that we studied was something called an isoelectronic species. An isoelectronic species is simply atoms or a group of atoms that have the same number of electrons. Okay, I'm going to highlight that. I'm going to underline it in red. That's really important. They're atoms that have the same number of electrons. All right, so let's take a look at this periodic table here and see different atoms, how many electrons they have. All right, so you can see Ne. How many electrons does Ne have? 10. Okay, very good. B, how many electrons? 5. Li, how many electrons? 3. All right, do you see any atoms, they have the same electrons? So maybe you noticed that no two elements on the periodic table have the same number of electrons as atoms. But what if we make ions? You remember we studied that group 1 makes +1, group 2 makes +2, group 3 makes +3. We're going to skip group 4. Then we go -3, -2, -1, 0. Okay, so now, how many electrons does Ne have? Ne has 10 electrons. How many electrons does F minus 1 have? Okay, so when F forms an ion, it forms a -1 ion. So, how many electrons will it have? F minus 1. It will have not 9, we're going to add 1. Remember, -1, it means add 1. So it's going to be 10 electrons. So now these two, they are isoelectronic because they have the same electron. All right? Let's look at O. How many electrons O has? Has 8. But what if I have O minus 2? I should add 2. Now that's 10 electrons. Oh, so this is also in the isoelectronic series. They all have 10 electrons. Let's do another one. N. Okay, we did F already. N. How many electrons N has? 7. But what about 7 minus 3? So what does it mean minus 3? It means add 3 electrons. So now it has 10. So this is also in the isoelectronic series. All right, now these are all of the non-metals. Now let's see if we can find a metal that's in the same isoelectronic series. Let's see Na. All right, Na is +1. So how many electrons Na has? It has 11. But what if I have Na +1? Does it mean I add 1 electron? No, it means you minus 1 electron. So it's 10 because you're losing negatives. +1, it means you lost a negative. And metals lose electrons. So here, Na is also in the same isoelectronic series. Let's do another one. Mg. Mg, how many electrons Mg has? Why isn't that going? Oh, goodness. Okay, how many electrons Mg has? Kind of hard to see it, but it's 12. All right, so Mg has 12. But what about Mg +2? What does it mean +2? Does it mean +2? No, it means -2 electrons, so it's 10. So all of these are in the same isoelectronic series because they have the same number of electrons. All right, now let's put these atoms in order of size. Who's the biggest and who's the smallest? Now we said if you are minus, the minus, it means you gain electrons. So these are going to be big. Okay, now which one do you think is the biggest? F minus 1 or F minus 2 or O minus 2 or N minus 3? Which one is the biggest? Gain 1 or gain 2 or gain 3? The biggest one is gain 3. So it's going to be N minus 3 is the biggest. Okay, then we're going to have O minus 2 is the next one. Then we're going to have F minus 1. That's the next biggest, okay? All right, now let's look at the plus. Remember, the pluses, they're going to be small because you are losing electrons. Minus you gain, plus you lose. So these are going to be small. So who's going to be smaller? Lose 1 or lose 2? If you lose 2, you will be smaller. So the smallest one is Mg plus 2. And then bigger than that is Na plus 1. And then in the middle, we have Ne, which is the noble gas. That's going to be the one we have there in the middle. All right, so I'm going to put here Ne, and it's going to be like this. Okay, so you need to know this, okay? You need to know how to put them in the correct order. So the negatives, they are the biggest. The positives, they are the smallest. And the noble gas is in the middle. Okay, if you think you're ready, you can go to Class Kick. And we solved pages 5, 6, and 7 in the class. I think on page 7, you have some classwork in Class Kick. Okay, I'm going to lock this assignment soon, so please get this done. Page 7 in Class Kick. In notes 3.1. Good luck.